Okay, I think we can start. Hello, ladies and gentlemen. Hope you've had a great lunch and hopefully a cup of coffee and you're ready for the next session. My name is Jordanov. I'm here with my colleague Ivaylo Duevski, and we are going to present you a couple of solutions for test automation frameworks based on our experience and our work in VMware. So first, let me start with who we are and what we are doing. We develop different automation tools with the target to prove the quality of the product Site Recovery Manager, known as SRM. A few words about SRM. SRM provides disaster recovery capability of virtual infrastructure and migration from one virtual center into another. We are not going into details about SRM, we don't have enough time for this, but what is interesting from automation perspective is that SRM is built on top of a platform, vSphere platform. It uses different replication technologies, and we need to integrate many APIs and even external frameworks into our test automation. Also, SRM has web-based user interface, which is a plugin extension to vSphere web client that is written on Flex. So major part of our work is automating UI written on Flex that produces Flash to the web browser. So before we deep dive, let me talk about why we need test automation frameworks in general. So the short answer is the same reason we need development frameworks. It provides technical implementation guideline to write readable, extensible, reusable code. All of these magic keywords there. So maybe more relevant question is, do we really need clean code in our automation? Since automation code is not deployed on production, it only validates the product. We believe, and I'm sure most of you agree, that the answer is yes. We rely on the automation to ship the product with high quality, and we should not compromise the automation code itself. And even what we say and what is our goal is that automation code should have product code quality. So one of the bases for our framework is Selenium. And we start with Selenium. Could you please raise your hand if you are familiar with Selenium? Cool, thanks. So we start with this sample. Is there any problem with this? Can we improve it somehow? Some people could say, if it works, don't touch. If it's stable. I remember one of the greatest Bulgarian football coaches, Dimitar Penev, once said, на български ще го кажа, ако отбора побеждава, с мене не се правят. But obviously it's hard to reuse, there are a lot of hard-coded pieces inside, so we can define some methods to encapsulate, to reuse, but this doesn't improve the things a lot. We still have a lot of hard-coded pieces inside. Our tests still use low-level details, Selenium driver details are inside our test. So what we can do more to improve the things is page object pattern. Could you please raise your hand again if you, at least you've heard about page object pattern? Great. Okay. Few words about page object pattern. It's initially described by this nice guy, Martin Fowler, under the name window driver in 2003, 2004. Later, Selenium makes it popular with the name page object. So generally, it hides the underlying UI and provides higher level API to access our objects. It hides the UI specifics from the rest of the software and from our tests. So with page object pattern implemented, now we can represent the screens of our application, a series of objects, so that in order to access a text field, for example, you should have methods that accept strings and return strings. Checkboxes should use booleans. the button should have corresponding actions. We have higher level API to access our underlying UI. Another interesting thing, despite the term page, there is no need a single object to represent an entire page of the site. It could be just elements or section that appears many times in our site. So we implemented the page object, and now we have so-called UI harness abstraction, which means now we have a framework layer that defines an abstraction model to access our components. But this didn't solve all our problems, all our issues. For example, talking about Flex, we faced some performance issues. For some UI elements, we were not able to search by complex criteria, and because we were limited into the Selenium driver library. So we needed to go further, and also we had to integrate some external frameworks. This guy on the right side that we haven't talked about. So we need to go further, and now I will let Ivaylo to share some more interesting techniques, how we can dynamically load automation modules, how we can integrate these external frameworks into our tests, and even how we can optimize more using dynamical class structures. Go.
Thanks a lot, Ivan, for this introduction into test automation frameworks and into page object. So I would first like us to give some more attention to page object, because as Ivan mentioned, we started using page object in our framework, but this didn't solve all of our problems with the design of automation code. And the reason is simply that page object is a design solution for the tests. It looks great from the point of view of tests and gives them a higher level API to automate test scenarios. But inside the page object implementation, we are still stuck with the same low-level driver API that we were trying to avoid in the tests. And the problem with most driver APIs is that the API is really simple and usable. It wants everybody to be able to use it in any environment. But the cost for being so simple is that the driver API is actually coupled with a lot of low-level details. And here's one typical example of driver API for UI automation. So whenever we need a button automation object, we have to create it with the code new button with parameters string component ID and Selenium object. And the component ID is, in fact, not just a plain string. As you can see, it has some internal structure. It's actually a tree path in the tree structure of UI components. And this example is not so specific. You have pretty much the same case with the well-known Selenium WebDriver API with the web element class and find element by. Since you were familiar with Selenium, I guess you know very well what I'm talking about. And the problem is that this code, new button, is not reusable. You have to write it every single time whenever you need a component. And every single time you write this code, you need to know all the details. You need to know the exact component type, which may be one of 100 component types in the driver library. You need to know the exact component ID. You need to worry about the structure of the ID. And you need to worry about any service dependencies like the Selenium object. And all this is, in fact, low-level driver infrastructure. This is not our high-level concern, because in a page, even if you look at it as a manual user, in a page, our high-level concern is different. Our high-level concern is just to find this button and click it. And so the question is, if you have such a case with getting stuck with low-level details and a design that doesn't work for us, how do we optimize this? how do we optimize a design that doesn't work well for us? And the answer is we need to find a design concept that matches our important high-level concern. And inside page object, our high-level concern was just to find a component in the component structure in the UI. So we can rephrase the design question like this. How can we create a code model for the UI component structure? And I think for this question we have one pretty easy answer, because the UI component structure is a typical example of object-oriented design. And we can easily describe it in any object-oriented programming language. And this was exactly what we did in our framework. We matched the UI component structure with a declarative structure of Java classes, like the one you can see right now on the screen. And if you look at this structure, even not very carefully, just at first glance, I think you agree that you can see how it is very similar to a sketch of the real UI. And you can see where each component is. You can see the exact type of each component, if it's a label, button, field, or whatever. You can also see the structural patterns. You can see how components are nested inside structures of components. You can see how structures are nested inside other structures. And this is just like the real UI. And of course, it is too complex to describe the complete real UI in this way. But for automation purposes, this class structure is enough to describe the UI components and their correct structure that we need to do our automation. And except components, of course, they have some data dependencies to make them work. And as for the data properties of components, such as the component IDs, we use the same approach, a declarative approach. We declared the component IDs for a class of components in a separate class, just not to mix the higher concern with the low concern. The classes are separate. And we used a very simple convention to link a component to its component ID. Our convention is simply that a component and the ID for that component have the same name in the code. So for example, for the component called title, the ID is called just ID title. For artist, the ID is called ID artist, and so on for all components in the structure. And I can tell you that in our framework, these two classes are all the code you need to write to describe and to make work all of your components. And you write this code only one time. Whenever you need to use the components, you just reference it. And the cool thing from my perspective is that the low-level details are all handled by the framework behind the scenes. Low-level details like the creation of components, the data injection of IDs to components, building the complex structured ID required by the driver by following the structure of the classes, dependency injection of any services like Selenium, all this is handled by the framework, and you don't need to write any code about any of that. And seems a lot of people are doing UI automation today, judging by the responses to Selenium and page objects. So you probably know that declarative structures are not something unique and brand new. And in some smarter driver APIs, you can even find them as a built-in feature. But in our framework, we did not have this feature, and we decided to implement it from scratch. And even we are using it not only for components, it's kind of a pattern in our framework. We use it for many things. And of course, there's some cost to implement this in the framework. And I'd like to just to summarize why did we think it was worth to invest the effort to implement such framework features. And you know, as automation engineers, we are automating the testing of our products. But with optimized designs like the declarative structures, we are going a step further. We are automating automation itself. We are kind of automating the way we develop automation. It is as if you are having the framework be a coder. It writes, instead of us, those pieces of the code that we don't need to care about. And in this way, the framework can help us to get unstuck from low-level concerns at any layer of our automation, high or low. On every layer, we can do the necessary things to focus only on the high-level concern. And this is important because in the real world, our automation is not just a few lines of code, like the ones we showed. In the real world, we are testing large and complex UIs and software products. We have many people and many teams working on automation. And in this environment, if our framework is full of low-level concerns, at some point, we are starting to feel more and more clearly that all of our people and teams are wasting a lot of time just to handle low-level concerns and to smooth out everything related to making low-level concerns work. And automating automation is valuable exactly because it gives us a way to minimize and to save this wasted time. Okay, so we are done with automating automation, and we're going to switch topics now. Our next topic is not so closely related, it's different. Our next topic is automation plugins. And here we're not going to talk about high-level abstractions. With automation plugins, we're going to show how we can use plugin architecture in our automation infrastructure to optimize the low-level driver APIs in our automation framework. And here you can see one example from the real world. This is actually the architecture of Selenium, in which we do automation of web applications. And you can see that our low-level driver API is actually it is a client-server API. On the automation client side, we have just a driver client module, like the Selenium Java client library or in any other language. And our automation framework uses the driver client to call the driver API. But the actual driver API actually lives on the other side. It is embedded inside our tested application. And let's think about what happens to our application as our development team keeps adding new features to it. It's very likely that at some point our developers are going to migrate to a plugin architecture, or maybe they started with it from the very beginning. And to create new functionality for our application, our developers are just going to create a UI plugin, and they're just going to load this UI plugin into the application. And inside this UI plugin, there will be some new and complex UI component, as you can see here, which is so new and complex and unexpected as a new feature because that our existing driver API doesn't know how to handle this component. So we cannot automate it with the existing driver API. So now if we want to automate this component, we really need to extend our driver API and the important part of it, which is inside the application. We need to fill the place of the regex. And there are different ways to address this problem with missing driver API, but my statement is that the smart way would be to do the same that the developers did. So we can just write our new driver API in our own driver plugin, and we can just load this driver plugin into the application in the same way, using the same mechanism as the UI plugin was loaded. And it will be even better if we do not deploy our driver plugin on the production server where the application came from. Even better if we deploy our own automation server, which is part of the automation infrastructure that we control, and we make our application to load, we make our application load our driver plugins from our own automation server. And why did we do all that, and what was the value of it? The value is that in this configuration, if we want to change our driver API, all we need to do is to write some new code in the driver plugin and deploy this driver plugin on the automation server. And the important point is that all these changes are limited to the automation infrastructure. For these changes, we do not need to touch our tested product anymore at all. And this is exactly the big advantage of automation plugins. This is their value. Because without automation plugins, Changing our driver API in the application is usually a very complex process, and in the course of this process we are actually changing our tested product. And this process is so complex that we hardly ever do it. There are not much cases where we will dare to change our driver API. Usually we say, this is the driver API we have, and the automation we can do is limited by it. We cannot do anything more than the driver API can. But with plugins, we just managed to extend a driver API using means and infrastructure which is fully in our control. With automation plugins, we can just enable new automation features in our product without changing the product anymore. And that was also my conclusion for automation plugins. And our next topic is integration of external automation frameworks into our own automation framework. And I would like first to explain how we came to apply this idea in practice. So as Ivan told us, in our work we are testing a product that works as a solution on top of a platform. And in this case, when you're doing automation for this product, as we did, when we started building our automation framework, of course that we wanted to reuse the existing automation for the platform products because it gives us a lot of ready building blocks for our own test cases. And there are different ways to reduce automation. One very trivial and not recommended way is just to copy-paste code. But we wanted to do something different. In our environment, all teams are using the same programming language for automation, which was Java. And this is also a great environment to copy-paste code. But we still wanted to do something different. We wanted to optimize the way we use automation. We wanted full integration of external automation frameworks and all their automation code into our framework. And this means that we just wanted our framework to load external frameworks in the same process, like Java libraries. And in this way, we wanted to call any code from external frameworks like a normal Java API. So, great idea, but when we started trying to implement it, very quickly we found out that this is not so easy. And this was simply because external frameworks are in fact not libraries. They are independent applications which were made to address the automation requirements of other teams and other products. And they are, in fact, were not made to be reused. And the major challenge that we faced trying to fully integrate external frameworks was that our framework and the external framework had incompatible designs. So let me give an example. What exactly do I mean by incompatible designs? So here's the external framework, and it has inside a lot of reusable code. It's very useful to us, and we want to call all of it. But inside the external framework, this code makes hard references to some service object for which the external framework has only one instance. And that's why we're going to call it the singleton service. For example, the singleton service can be some client object that knows how to talk to some server. And in the external framework, they have only one such server. So they need only one client object. And then here comes our framework. And imagine that in our product, we simply have many servers of the same kind. So we need many service objects of the same kind with different configuration. And the external framework has only one such service, hard-coded. And in this configuration, if our framework just tries to call the code of the external framework like a normal Java API, it cannot do that because the whole external code is hard-coded to the singleton service. It is not configurable, and it simply doesn't have a way to handle our many services. So there's another side to this challenge too, and we have to assume that the external framework design doesn't fit us, but this design will not ever be changed. And this is simply because if you go to the external team that maintains the external framework, and we just ask them, hey guys, could you please refactor your whole framework for our purposes? Chances are that they're going to say no. And they are going to have many reasons.
They say no.
And the bad thing is most of these reasons will be valid, but they will say no, and we probably won't have a way to change that. So here's our challenge to full integration. If we want to do full integration, we must take the external framework as is, as it comes, without modification, and we need to find technical solutions to any problems with incompatible designs. And to conclude our session, I would like to present to you, just in brief, 3 different solutions that we found for the singleton service problem, because we faced it several times in our practice with several frameworks. We're going to look at 3 different solutions for it. And my point with this is just to convince you that such solutions exist. That problems like this are not easy, but they can be solved. And this is exactly the kind of solutions that can help us to reuse automation in the real world. So, going forward, this is our solution number 1 to the singleton service problem. So our design problem is that we actually want to have many instances of the singleton services. Many instances of the singleton service, sorry, which is only one. And we can address this in a straightforward manner by just having many instances of the whole external framework. And in each instance of the external framework, we can put one instance of our many services. And we also want all this to run in the same process, so we do not treat the external framework as a standalone application anymore. Instead of this, we pack the external framework in some format for virtual applications, which allows the application, the same application, to run many times in the same process. And we run all these virtual applications with external frameworks and our framework. We run all this in the same process. And virtual applications, this sounds a little too abstract, but if you wonder what exactly are we doing here, actually this is quite easy to do if we are using some general purpose application platform to run our frameworks. For instance, application platform like Eclipse Equinox, which is the platform running Eclipse plugins. And in this case, we can just pack the external framework as in the application format supported by our application platform. For instance, we can pack it as an Eclipse plugin or as an OSJ bundle, which is what the Eclipse plugin is, in fact, in the core. And we can just run as many copies of this application package as we want on our application platform. So in short, what are the pros and cons of the virtual application solution? The plus is that it is a straightforward solution. We don't need to think too much about it. We can just take some application platform and run it. And the main disadvantage is resource consumption, because it is likely that running the whole external framework many times will consume a lot of resources. And so if we don't like this disadvantage, the resource consumption, we have another solution. It is called context switching, and this is a lightweight solution in which we do not multiplicate the external framework. We use a single copy. And we solve our design problem in another way. So our design problem is that we have many services in our framework and a singleton service in the external framework. And so we can just think of the singleton service as a virtual CPU that we need to run our many services on. And we can apply to this configuration the same context switching that the operating system uses to run many threads on a single CPU. So whenever we want the external framework to use one of our many services, we can just switch our service inside the singleton service. And here's how it works in some more detail. In our framework, we have an interception module, and we route all our calls to the external framework to this interceptor. And when the interceptor catches an external call, the first thing the interceptor does is to find which one of our services is making this call. In this case, it's service 1, and to set this service inside the singleton service. And then the interceptor allows the call to proceed into the external framework. Later on, when the call down the code path reaches the singleton service and wants to reference it, it finds our service there. And the same set and call sequence is repeated for each of our external calls and for each instance of our many services. So pros and cons. The plus is that this is a lightweight solution. It doesn't consume a lot of resources. It is also relatively easy to implement. We need just the interceptor module logic, which is inside our own framework, which is a plus that we control it. And the obvious disadvantage is that context switching, by definition, is a synchronized pattern. So at any given time, only one of our services can occupy the singleton service, which means that at any given time, we can have only one active call to the external framework. So any next calls must wait for the previous call to finish before proceeding. And if we don't like the synchronization constraint of context switching, this is our last solution that we're going to discuss. We have called it context injection. And this is an improvement of context switching which doesn't have a synchronization constraint. And to implement and support it, we invert the control. Instead of setting services into the external framework, we make the external framework get services from our framework. Simple. And here's how this works. Once again, we have our interceptor for external call. And this time, the interceptor catches an external call, but when it catches such call, it only saves which one of our services is making this call in the context of the current thread. And then the interceptor allows the call to proceed into the external framework. And later on, when the call reaches the singleton service, we have a certain way, I will explain in a minute exactly what way, but we have a certain way to make the singleton service call back to our framework and get our own service object. And this sequence of save, call, and get is repeated again for each external call and each instance of our many services. And obviously the interesting part here is how exactly do we make the external framework get services from our framework. And to support that, we need to apply a programming technique called instrumentation. Instrumentation usually means to do something for performance purposes, but in more general context, it means to modify the normal behavior of external code. And in our case, to make the external framework get services from us, we need, for instance, to replace the singleton service with our own proxy module that knows how to get our services, or to install another interceptor in the external framework that knows how to provide our services to the external reusable code. So pros and cons, to finish with this. Context injection is a powerful solution. It is not synchronized because these save, call, and get sequences can happen in parallel in this case. So our calls don't need to be synchronized anymore. And the obvious disadvantage is the greater complexity. To make this solution work, we need to apply instrumentation. And if you wonder how instrumentation works in practice, in higher level programming language like Java, there are instrumentation tools in libraries. For our solution in Java, we have used the AspectJ library for Java to instrument the external framework. So this was my really final topic about advanced solutions that we implemented in our automation framework, and I would like to hand back over to Ivan for a few words in conclusion.
Thank you, Ivaylo. Ivaylo can fill 2 hours easily. Okay. I hope you listen to Ivaylo carefully. I have a question for you. So, what does this code do? No. Sorry, it was a joke. I just wanted to provoke your attention. So what I want to stress really, and to stress again on why we are doing all of these complexities and solutions that we've been talking about. Actually, we want to be easy. We want to hide the automation complexities inside the framework, so that when you write or when you read the test case to test automation, to feel like reading test case, to feel like reading test steps, and to be able to focus on the functional aspect. Because have you seen an automation code that somehow fits and work around a bug instead of just catch it? I've seen it, and the main reason was because while programming, the focus had been so much on the programming details, on the technical details, that somehow the functional aspect was missed. I believe, at least with all of these approaches, we help to avoid this. And the second big value, if one day we decide to change the whole UI technology, for example with H5, we want to reuse as maximum as possible, maximum of our automation work. These are the values that this is the reason we invest in all of these complexities. And now, I really have a question for you. And the first correct answer wins this back. So, who is the Hollywood body count champions? Come on, who has most frags? Guess something.
Arnold.
No, next. No, come on. Yes. Where was the correct answer? No. Okay. You won the bag for this behind you, the seat. Thank you. No. It's not allowed. He's in VMware right now. So thank you. This was everything from us. Now, if you have any questions, comments are more than welcome. Something like, what the hell are you doing? Any questions? Great. Okay. You can reach us around the expo booth if you later if you decide to ask something. Thank you.
Thank you.